Alright, so we have two posts located on the sides. One is 12 feet high and the other is 28 feet high. They stand 30 feet apart. They are to be steadied by two wires attached to a single stake. So here's wire 1, here's wire 2. Running from ground level to the top of each post, where should the stoke be placed to use the least amount of wire? So first thing we want to do is create two triangles for this problem. So you have triangle number 1, height of 12, base, let's say X. So we'll label that X, and then this area here is Y. So hopefully you recognize that that is a 90-degree triangle, which means we can use Pythagorean theorem. So Pythagorean theorem would allow us to solve for Y. So you'd have 12 squared plus X squared equals Y squared. So that would kind of help us see triangle number 1. And then triangle number 2 is over here. Its base would be the leftover ground length, so 30 minus X. Since this is X, this would be 30 minus X. Pole height of 28. And then we'll call the wire length here Z. So that would be like 28 squared plus 30 minus X squared equals Z squared. And our goal is to minimize Y and Z. So our minimal equation, or the equation we're trying to minimize, would be Y plus Z. That's the equation we are trying to be the smallest, so that we would use the least amount of wire. So over here we can already see that we kind of have multiple variables sort of happening. So I would take my first equation and solve for Y. So that I get Y equals the square root of 144 plus X squared. And I would take my second equation and solve for Z. So Z would equal the square root of 30 minus X squared plus 28 squared. That's now in terms of X. This is now in terms of X. So we could rewrite W so that if we substitute in Y and we substitute in Z, it is all in terms of X. And since our goal is to minimize that wire, we're going to find the derivative or minimization of this equation. So your 1/2 and 2's cancel, your x remains up top, the rest drops down. One half and 2 cancel, negative distributes in, so you get x minus 30. The rest drops down. And then this is where this becomes a calculator problem, because we've now gotten to quantities that are unsolvable. So the directions or the free response might ask you to find W prime, which is the answer we just found, and then they might actually give you points for finding the remainder of that answer. So you would get your points for W prime, and then you would get your points for finding the zeros of W prime. So you could type that in on your graphing calculator. Okay, so you can see I used like the alpha y equals technique to get my fractions. I double check to make sure all my squares are in the right place, and then I am going to go over to my graph. But just thinking about these answers sort of in general, the hypotenuse of a triangle is the longest side, right? So if this length is 12 and this length is 28, I know that my window should be no shorter than 12. So there's like, I'm going to adjust my window so that my y min is, I mean, there's no way it can be 12 or smaller. And then the base of this whole triangle is 30. So again, I know my y max is probably going to be out there pretty big, especially if this is 28. So I might take my y values out to like 75. So I'm going to change my y min to 12, my y max to 75. I'm just going to change my x scale to 5. And then once again, my y values are never going to be 0. And I'm just going to make my, it really doesn't even matter. You can make them 10, 20. You're looking for your zeros. So not a big deal kind of what your y values are. And actually, I guess leaving the negatives will just help see the zeros a little easier. Okay, so looks like there's something happening over here, and then it's kind of increasing. So let's go kind of look in and see what's happening. Maybe I'm going to move my graph a little bit more that way, just to make it easier. There you go. So I zoomed in just a little bit more where I could see what was happening. So like I said, it's better to pull out, see the bigger picture, and then sort of zoom into what you can see. So we'll go to second trace, go to 0. We're going to move my little cursor to the left or to the right. Enter, 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 and we get an X value of 9. So what that means is that when I plug 9 back in here, we get 144 plus 9 squared, and then we get its square root, and that will give me my Y value. If I plug 9 in over here, that will give me my Z value. So X equals 9 is the value at which this is going to be minimized. You can kind of see over here that this is the original equation, not the derivative that we're looking at. So you can see how my derivative is sort of linear looking and how that's more curved. So the zeros of this function will occur at X equals 9. Okay. So then it says, where should the stake be placed? The stake should be placed at X equals 9. So the stake should be placed right here at 9 feet from the first tower. So as a sentence, it would be the stake should be placed 9 feet from the 12-foot pole. That will minimize the amount of wire. Okay. Example number 6. Rick wants to make Morty a holiday decoration. Rick has 4 feet of wire that can be used to form a square and or a circle. Why the board does that. Okay. How much wire should Rick use for the square, and how much wire should he use for the circle in order to create ornaments with the maximum total area? So this is a lot like problem number 9 was on last night's homework. The differences in number 9, I gave you the table to try to give you some ideas of X values to plug in, where here we don't have any ideas or values to plug in. We have to find them solely based on the critical points of our equations. So once again, we're looking at 2 equations. We're looking at the equation for area. So area of a square and area of a circle is x squared plus pi r squared. And then we know that we have 4 feet. That 4 feet represents our perimeter. And the perimeter of the ornaments would be 4x for the square and 2 pi r for the circumference. So you have area and perimeter as 2 equations. And then what we're going to do is substitute for a variable from one equation in to the other. So I'm going to substitute in for r with x's. So I'm going to use the perimeter equation to solve for r. So I get that r is equal to 4 minus 4x over 2 pi. If you wanted to, you could simplify or reduce that down. and say that r is equal to 2 minus 2x all over pi by taking out a factor of 2 from each of those. Then we're going to substitute that into the formula we are trying to maximize. So we're going to say that area is equal to x squared plus pi times 2 minus 2x over pi squared. So you get x squared plus pi, 2 minus 2x squared, all over pi squared. So I distributed the squared to both the top and the bottom, but I left them sort of separate so that I could cancel this pi with that pi. And then you have the choice of if you want to factor and FOIL now, or if you want to do your chain rule and then simplify. So if we simplify now, this becomes x squared plus 2 times 2, which is 4 over pi. 2x times 2 is 4x, but you would have to double that, making it minus 8x over pi. And then 2 times 2 is 4, x squared over pi. So a prime would become 2x plus 4 pi is a constant, so that zeroes out. If we do the second x squared here to get the x's side by side, 2 times 4 is 8 over pi x. And then the derivative of 8 pi over x is minus 8 pi. And then, as usual, we set that equal to 0. And once again, in terms of being able to find the zeros of this problem, you're going to need a calculator. Not that you couldn't like sort of solve for x, because you could add over 8 pi and then take out a 2 plus 8 pi, leaving you x. So x would kind of be like 8 over pi all over 2 plus 8 over pi. But I wouldn't anticipate you to know what that represented as a value. So that's where you would take your calculator and approximate. Here we get x equals 0.56. So, this is kind of like an EVT problem because we have a minimum amount of wire and a maximum amount of wire and then our point in between. So this is your critical point. Your min wire would be 0, your max wire would be 4. So we really wouldn't need to care about if the x value was 0 because that would mean no square. However, according to our candidates test, it's important to check that. So that's kind of what that table I gave you on 9 was doing. So you have your x, and then you have your area. So in your graphic calculator, you might want to put in this formula. So if you know how you can make your table in ask mode. So what you could do is type in x squared plus pi times quantity 2 minus 2x all over pi, and then square that. And then rather than have to type in x every time, you can go to second table and you could type in the x values we care about, which are 0, 0.56, and 1. And the 1 came from the idea that if the perimeter of this circle was x equals 1, then he was using all of that wire. So we get 0.127, 0.56, and 1. So the reason you have to do your candidates test is if he were to make both ornaments, maximizing the area of both, then the total area would be 0.56. If he were to use all of the material to make a circle ornament and have no square, then the total area would be 1.2732. And if he made only a square and no circle, the area is 1. So it says, how much of the wire should Rick use for the square and how much did he use for the circle? So he should use x equals 0, which means no wire for the square and all wire for the circle in order to create an ornament with a max total area. So you should use no wire for the square and all wire for the ornament. Okay. And then yesterday we looked at that worksheet with the two equations. So I had started or talked about number 1 with a couple of you. So in number 1, we had s equals x squared plus y squared for our equation for the squares. And then we had two numbers being added together had to equal 10. So that was my x plus y equals 10. So you substituted this into that, found your derivative. We got x equals 5. Therefore, both numbers were 5. In number 2, it said find the non-negative numbers for x and y that sum to 75 and whose xy is as large as possible. So you had to substitute from x plus y equals 75 into p equals xy squared. And then you derived that, found your zeros. We found 2 zeros. So once again, this is kind of what we call the candidates test, where you have to check both the 25 and the 75. And we see that 25 would be a max, 75 would be a min. So this is using the second derivative test, where you find the second derivative and find if the number is positive or negative. That tells you max or min. You could also have done our handy dandy little sign chart where you had 25 and 75, and you compared the values to the left and to the right. So it was positive, negative, positive, thus making 25 a max and 75 a min. So again, either test is fine. I tend to try to use both just because some people are comfortable with different methods. So, and it's actually easier to type on a computer with that one. So, again, you have to use your max or min test when you get to critical points. So since 25 is my max, I would find my second number by doing 25 plus 50 is 75. Number three gets a little trickier because they start to give your equations in terms of V naughts and T's. So now you have to go back and sort of find the missing parts using what we know and what we know about gravity and the pull of gravity on Earth. So the primary equation that you had or were given was H equals V naught T minus 16T squared. And again, those of you in physics should know that represents 1/2 G. We've also talked about it in here. That's like your generic equation for height. Sometimes you use D or delta. And then our second equation came from being told the height was 518 feet. So then what we did was replace H with 518